Alright, welcome to section 1.5, linear inequalities in one variable, and we are not covering objective 5. Okay, so we have 4 inequality symbols. Let's take a look at what they have. So we have something, like let's say maybe we had x less than a number. This symbol here is what we would consider less than if our variable is on the left-hand side. Okay, so our variable is less than. If we have our variable still on the left side, and we use this symbol here of a number, we're saying x is greater than. Those are 2 symbols down. We have 2 more to go. They're very similar to the other 2. So we have x less than, or, and we'll put this little line under the bottom. That means x is less than or equal to. And the other one, x is greater than or equal to a number. Okay. So now something else which we call interval notation, and it has to do kind of with our inequalities. So if we have our number line here, sorry, it's not perfectly straight. And we have some number, let's say a, and some number, let's say b. We can describe the answers that we have with those values. So we could say we have a number between a and b. And notice I have these open circles here. That means we go up to a, but we do not include it. So it'd be similar to these 2 here. That'd be an open circle, means we're not including those numbers in our answer. However, if I filled in those circles, that means that I would include them. So how would I do this in interval notation? Let me go ahead and erase a teeny bit of this to show both of the intervals. So this in interval notation would be, I'm including a, so I'm going to use a bracket here for including a, and then I go all the way up until b, but I'm not including b, so I'll use my parentheses here. Okay, there are many different options for interval notation, but the basic concept is, if you're including the value, which means you fill in the bubble, you'll also use a bracket for when you're describing it in interval notation. So once again, please note, this is graphing. Interval notation is this item up here. Alright, another way to show for graphing, if you want to, that makes interval notation a little different, instead of using the bubbles, you can just straight up use these values on interval notation. So you could just use from a to b. I find this is a little harder to read on a graph, so I prefer to use the bubbles. Either one is acceptable. Alrighty, and that is a basic example on interval notation. That is not the straight up definition, so if you want the real definition, please go ahead and read in your book. So example 1, graph the following inequalities and write them in interval notation. Alright, so what do we have going on here? We have our variable on the left-hand side, awesome, and then this symbol here, 4. So the question is this a greater than or less than? Well, the way some people like to describe it is if this was Pac-Man, for example, he always goes for the bigger item, right? So since his mouth is open towards the x, we know that x is greater than 4. So I'll go ahead and write this out. You would not need to write out what it means on an exam, but I'm going to write that out for you. X is greater than 4. So let's go ahead and graph that. So we have our, let's see, what point are we focusing on? The 4, right? So we have 4, and we want x to be greater than it. So which side am I going to be focusing on? Well, the negatives are over here, and the positives are over here. X is supposed to be greater than. So that means we're going to go ahead and head up in this direction. It doesn't say where we stop, though. It just says x is greater than. There is no limit on how much greater it is. Okay, and lastly, should we fill in this bubble or not? Well, since we don't have that line underneath our inequality sign, we're not going to fill in the bubble. Alright, and then for interval notation, let's see, so we start at 4, we don't include it. Oh, one thing to note, when you're reading interval notation, read from left to right, like you would in a book. So we start at 4, but we don't include 4, and then we go until, well, we said there was no limit, right? So, to infinity and beyond, right? As Buzz Lightyear would say. So, we'll go ahead to infinity, positive infinity, but we never actually can touch the end of infinity, so we always use the parentheses with infinity. And there we go. That is our answer. Okay, so we have x less than or equal to negative 3. So this is x is less than or equal to negative 3. So let's go ahead, negative 3 is here. Oh, another thing to do, sorry. Please always indicate where 0 is on your graph. Always do that. I forgot to put that down. Okay, so since x is supposed to be less than, it's going to be on the left side. So it's going to be all these values here. And once again, we don't have an end to that, what it is. It's just less than. And are we going to fill in the bubble? The answer is yes. We have that equal to symbol down there. So we're going to go ahead and fill in that bubble. So when we're writing interval notation, we always read from left to right. So what's our starting number on this side? Well, there is no starting number. It's just negative infinity, right? So we start from negative infinity, and we're going up until, oops, we stop right here at negative 3. And we include negative 3 because it is filled in, and we had that equality symbol there. So here's a question. Is there a difference in operations when solving equations and solving inequalities? So solving equations and solving inequalities, is there a difference? Well, there is one major difference, and that is, so the answer is going to be yes, if we multiply or divide by a negative. This is the only difference. We can add numbers and we can subtract numbers. We can multiply positives, divide by positives. But if we multiply or divide by a negative, something happens that's different than equations. What happens? We flip our signs. And please note, this has to happen on the same step as the division. Or the multiplication. So when you're solving, make sure to flip the sign on the exact same step. So let's take a look at example 2. Solve the following linear inequalities in one variable. Answer with the graph and interval notation. Okay, well, one thing first. How do I know this is linear, and then how do I know it's an inequality? Well, I know it's an inequality because I have an inequality symbol. Awesome. And then it's linear because we only have x to the first power. Okay, so that's simple. So now we know how to solve a linear inequality. As usual, simplify both sides first. This side is as simple as possible, but this side should be simplified. Let's go ahead and multiply in that negative 2. We have 5 minus 2x plus 8 less than or equal to 11 minus 4x. Okay, let's still keep simplifying that left-hand side. The 5 and the 8, so that's going to be 13. Negative 2x plus 13 less than or equal to 11 minus 4x. Okay, so both sides are simplified. Let's go ahead and, and we're going to go ahead and let's add 2x to both sides. Okay, so since we added, we don't need to worry about flipping our sign. And let's go ahead and move an 11 to the other side. So that means I'm going to subtract 11 to get rid of that positive 11. Okay, so once again, we still don't flip the sign because we only added and subtracted. So now we're trying to get our variable by itself. So how do we get x by itself? It's being multiplied by a negative 2. So to undo that, we're going to divide by a negative 2, but what happened here? I just divided by a negative 2, right? So the only time we flip our sign is if we divide or multiply by a negative, which means I have to go ahead and flip the sign. So please flip it on the step you show the division. Don't flip it after. That is something that points will get docked for that. Okay, so then we have 2 divided by negative 2. That simplifies to negative 1. Greater than or equal to x. Okay, so now let's go ahead and graph and answer an interval notation. To make it easier to graph, I'm going to go ahead and just switch how my equation looks. I'll just go ahead and flop it over. Nothing happened. I just rewrote it. That is the exact same way of rewriting it. So now this says that x is less than or equal to -1. Alright, so here's -1. Make sure to always mark where 0 is. And we want x to be less than, so it's going to be smaller than -1. And it's equal to, so we'll go ahead and fill in that equal to mark. And then for interval notation, starting from the left-hand side, moving to the right, we go from -infinity, and we read up, boop, until we hit -1. And we include -1, so we're going to go ahead and use that little staple. Think of stapling a piece of paper together. You're including them. Okay, so now B. Ooh, this one looks intense. Is it linear? Yes, because x is only to the first power. Let's see. Is it an inequality? Yes, because we have that inequality symbol. Okay, so now we know what we're dealing with. Always a good idea to check that out first. Let's go ahead and simplify both sides. So to do that, I'm going to go ahead to get rid of that parentheses there, and then distribute to get rid of that parentheses there. So that would be 3 over 4 times x minus 3 over 4 times 2 plus that half. Bring down the inequality symbol. And then 1 over 5 times x minus 1 over 5 times that 8. Okay, so simplifying. We can simplify the 2 and that 3, so there's only 2 left over down there. So we have 3 over 4x minus 3 over 2 plus a half greater than 1 over 5x minus, and we can't simplify that fraction, so it's 8 over 5. Simplifying both sides, we can go ahead and add these two together. We'll get 3 over 4x minus 2 over 2 greater than 1 over 5x minus 8 over 5. Okay. Well, both sides are almost simplified. This, actually, I can rewrite the 2 over 2 as 1. So I'm going to go ahead, replace the 2 over 2 with 1. So now let's go ahead and get the x's on one side. So I'll go ahead and minus the 5th x minus the 5th x. Ooh, this problem is definitely a little harder. So I'm going to go ahead and use my arrow to indicate where I've gone with my work. So I have 3 over 4x minus 1 over 5x minus 1 greater than negative 8 over 5. Okay, I still need to get x by itself, so I'm going to go ahead and add that 1 to both sides. And while I'm at that, see these two fractions here? I want to be able to add them, and at the moment I cannot. Why? Because they don't have the same denominator. Right now we have a 4 and a 5. I need to have a same denominator if I'm adding or subtracting a fraction. So what would a common denominator be? 20. So common denominator, 20. I'll go ahead and multiply the 4 by 5 to get 20. I have to do the building up property, so I have to multiply the top by 5 as well. And then I'll multiply the 5 by 4, and I have to multiply the top by 4 as well. That'll be 15 over 20x minus 4 over 20x is greater than negative 8 over 5 plus 1. Okay, so now let's go ahead and add the x values together. We have 15 over 20x's minus 4 over 20x's, which is going to be 11 over 20 x values. Greater than. Now, we want to add those fractions on the other side. So in order to add fractions, they need to have the same denominator. Right now, they do not. So 5 and 1. Well, I could go ahead and multiply the 1 by 5, and I'll end up with 5 over 5. So negative 8 plus 5 is going to give me negative 3. 5 on the bottom is going to stay as a 5. All right, so that's definitely a lot of work. How do we get x by itself? Well, we'll go ahead and multiply by the reciprocal of that fraction. So that'll be 20 over 11, 20 over 11. The 11's cancel out, 20's cancel out. We're left with x is greater than, and let's see, can we simplify this before we full on multiply it out? Can we simplify? The answer is yes. See that 5 and that 20? We can go ahead, 5 goes into itself once, and 5 goes into 20 4 times. So then we have negative 3 times over 1 times 4 of 11, and x is going to be greater than negative 12 over 11. Okay. We're not done yet, though. We got to go ahead and answer in graphs. Sorry, there's not a lot of space here. Let's go ahead and put my little graph in here. I'm going to go ahead and box this off so it's not in all of my work. So we have 0 here, negative 12 over 11. X is supposed to be greater than, but not equal to. So there we go, to that side. Greater than, but not equal to. So we're not going to fill in the bubble. And then interval notation, start from the left, read to the right. We start at negative 12 over 11, but we don't include it. And then we move on to infinity. Once again, we do not use a bracket with infinity symbols. Okay, so a 3-part inequality. What does that mean? Well, basically, it's when we've stuffed 2 inequalities together. So we'll have 2 different sides. So we have one value here, A, less than some value here, B, less than some value here, C. And we could use any of the inequality symbols here. These are just the generic ones I'm using here. So what happens is if I feel like adding some value, let's say y, to this side here, what I have to do is add that same value to all 3 sides. Same thing if I wanted to multiply, divide, or subtract. I have to do it to all 3 sides. Okay, it makes it a little more difficult. So usually what will happen when we're given a problem is our variable will be on the inside of our inequality, which means we're going to try to get rid of everything on the inside except for x. So that's our plan. Keep x on the inside, get rid of everything else. So if I'm looking at this, what is keeping x from being by itself? Well, we have that minus 5 and that negative 4. 2 things that are keeping x from being by itself, which means I have 2 operations to do. I always like to do the addition or subtraction first, and then I do the division and multiplication if I need to. So I want to get rid of that negative 5, so to get rid of a negative 5, we're going to add 5. But remember, I have to add it to all 3 sides. So I got to add 5 here, and add 5 there as well. So negative 2 plus 5 is going to be 3. Bring down that equal sign, or inequality. In the inside, we're only left with negative 4. Bring down that inequality, and we have 7 plus 5, which is 12. Hey, look at that. Our variable's almost by itself. How do we get it by itself? Well, we got to go ahead and divide by negative 4 to get rid of that negative 4 that's being multiplied to x. Divide by negative 4, divide by negative 4. Did I forget anything? I did. I need to swap my inequality symbols because I divided by a number. Alright, and then I have negative 3 over 4 greater than x, which is greater than or equal to 12 divided by negative 4 is going to be negative 3. Okay, so you can ask yourself, if I hadn't swapped the inequality symbols, what would this have looked like? Well, if I hadn't, notice this is just an example, if I hadn't swapped it, I would end up with this. And if I graphed that, I have 0, negative 3 over 4, and negative 3. If I hadn't swapped the inequality symbols, this would be saying that negative 3 is greater than negative 4. Which if you look at the number line, you'll realize that is false. Negative 3 is less than negative 3 over 4. Okay, so you do need to swap the inequality symbols, because if you don't, your answer will not make sense. Alright, so let's go ahead and graph our answer. Easiest thing that I like to do is graph it right below, because we can see this is our endpoint here, negative 3 over 4, and our endpoint here, negative 3. I like to use the bubble method, so I'll go ahead and plop in my bubbles, and our x is in between, so we'll go ahead and do that. The question is, do I fill in my bubbles or do I leave them empty? Well, for this one here, I don't fill it in, but for this one, I do. Let's go ahead, fill that in. And lastly, interval notation. So reading from left to right, first point we see here, and read here, and then we stop. So we start at negative 3 over 4, we don't include it, and then we go up to negative 3 and box it. And there we go. That is our answer. That is it for section, what was this? 1.5. If you have any questions, please come to me in an office hour or email for a different office hour setup.